Hey guys, today we're going to review over everything we've done in Unit 3 so far, which is all about polynomials. So the first two questions are asking us to determine the end behavior of the function. This one has f of x equals negative 3x cubed plus 4x squared minus x plus 1. So since they're asking us about end behavior, that means that I need to use the leading coefficient test. So leading coefficient test, I'm going to write this on the side. Helps us to figure out what the end behavior of a graph of a polynomial is going to be. So if the leading coefficient is positive and it has even degree, then both sides are going to point up. If your leading coefficient is negative and has even degree, then both sides are going to point down. If your leading coefficient is positive and your polynomial is of odd degree, then one side is pointing down while the right side points up. And if it's negative and odd, left side is up while the right side points down. So for this problem, your degree is your biggest exponent. So in this polynomial, our biggest exponent is 3, making this an odd degree function. Then my leading coefficient is whatever coefficient is in front. So in this one, I have a negative. So if it's odd and it's negative, according to my little chart over here, that's this one right here, the left side is going up and the right side is going down. So left is up, right is down. Okay, number 2. So same thing, determine the end behavior of the function. F of x equals 2x to the 4th power minus 5x squared minus 7. So look for the highest exponent. So in this case, our largest exponent is at 4. And 4 is an even number. Then look at the coefficient at the front of that term. And I have a 2. And that's positive 2. So in this case, it is even and it's positive, which means that both sides are going to point up. So left goes up and right goes up. Okay, our next problem. What is the equation of the polynomial with the given zeros and multiplicities? So what we're going to do is we're going to work backwards. Each zero, I want to turn it into a factor. So let's start with that x equals negative 1/2. If I want it to be a factor, the x and the number have to be on the same side of the equal sign and make it equal 0. So what I'm going to do is I'm going to add 1/2 to both sides. So that leaves me with x plus 1/2 equals 0. Okay, so it equals 0 like I want it to, but I don't like that fraction there. So in order to get that fraction to go away, we are going to multiply this entire thing by 2. I choose 2 because 2 is the denominator of that fraction. So now I'm going to distribute that 2 to each thing that's in here. And that gives me 2x plus 1 equals 0. So that looks a lot cleaner. So we're going to use that as our factor. 2x plus 1. Also, make sure you take note that for this one, for the 0 of negative 1/2, it told us that it has a multiplicity of 1. So your factor here is going to be raised to the 1 power. Now, normally we don't usually write that little 1, but because it says multiplicity 1, I just wanted you to Wanted you to see that. Okay, now let's do the other 0. So they tell us that we have a 0 of x equals 4. So same thing, I want to convert it into a factor, which means I want it to equal 0. So I'm going to subtract 4 from both sides. That gives me x minus 4 equals 0. Okay, so it equals 0. There's no fractions or anything. So I know that x minus 4 is my factor. But again, pay attention to what they're telling you. It has a multiplicity of 2. So in this case, you're going to have a little 2 as an exponent. So that might be something we need to write down. Use as exponent for your factor. That was supposed to be an A. So multiplicity is used as exponent. Okay, but now that I have both my factors, I can write my polynomial in factored form. That would be f of x equals 2x plus 1 and x minus 4 squared. So this is already the polynomial, it's just in factored form. I want to write it in standard form, which means that I want to multiply everything out. So I'm going to do 2 binomials at a time. So just be aware that anytime you have something squared, it means that it's there twice. So I could write this like this. So I'm going to start by multiplying this that's here first. Once I get that done, then I'll multiply the other one. So I'm going to use box method, so I'm going to do this kind of off to the side. I have x minus 4 times x minus 4. On the top left, x squared. Bottom left is negative 4x. Top right is negative 4x, and bottom right is positive 16. Okay, so for just that green part, I'm going to pull out everything from the box over here. So I had x squared. Then I have 2 terms that have x in them. So I'm going to combine them. Negative 4 and negative 4 would give me negative 8. And then my last thing is that plus 16. Okay, so we're almost there. But now I need to completely multiply what I have left over. So I'm going to do another box. This time it just needs to be a bigger box. It needs to be a 2 by 3. Okay, so I have 2x plus 1 times the trinomial that we just found. So x squared minus 8x plus 16. I'm going to do the top row first. So that would be 2x to the third power minus 16x squared plus plus 32x. And then now the bottom row. So plus x squared minus 8x plus 16. So I'm going to simplify as I take things out of the box. There's only one thing that has to the third power. But then I have 2 terms that have x squared. So we're going to combine those. That gives me minus 15x squared. Then I have 2 terms that have x's. So minus 8 and plus 32. So we would write that as plus 24x. And last, that constant plus 16. Okay, and that is my answer in standard form. Okay, question 4. The function f of x equals x to the 4th power minus 4x cubed plus 2x squared plus 4x minus 3 can be written in factored form as f of x equals x minus 1 squared, x minus 3, and x plus 1. Sketch the graph of this polynomial. Okay, so when you're sketching, you have a few steps to do. You want to know what the end behavior is. So actually, you know what? Let's go ahead and do that right now. So we're going to figure out our end behavior by looking at our leading coefficient test. So looking at the polynomial, and you can look at either one. So the one that's up here or this one, it's the same thing, it's just written in different ways. But I'm going to look at the original. I have the highest exponent being 4. So that means that it's an even polynomial. Other thing is that what's in front of that, I know there's really nothing there, but we understand it to be an invisible 1, and that's positive. So this function is positive and even. So positive and even, which means that both sides are going to point up. So left is going to point up and right is going to point up. That'll help us later on when we're sketching. Okay, second thing I want to do is I want to find the zeros. I want to know where it's going to cross the x-axis. So here's where this problem was super nice to us, and they already gave us what it would look like if we were to factor. So what we're going to do is set each factor equal to 0. That way we can find out where it's going to hit the x-axis. Okay, so let's start with the first one, x minus 1. Set it equal to 0. That means I need to add 1 to both sides. So x equals positive 1. But there is one thing to look at here. That factor was squared. It had a multiplicity of 2. So multiplicity of 2, which is an even multiplicity. So that means at that point, it is going to touch the x-axis at 1, but it's only going to touch and then bounce away. It's not going to go through. Okay, our next factor, x minus 3, set it equal to 0. So then I get x equals positive 3. This time, it doesn't have a power associated with it, so we know that it's just power of 1. So multiplicity of 1, which is an odd number. So that means that at the x-axis, at positive 3, it's going to go through. And then the last one, x plus 1 equals 0. Subtract 1 from both sides, so x equals negative 1. And this is the same as before. It doesn't have a power, so that means that it's a multiplicity of 1, which means that it's going to go through at negative 1. So I have my end behavior. I have my places where it's going to touch the x-axis. I just want to find a few more points so that I can get a better idea of what it's going to look like. So I'm going to make myself a table. Okay, so one point that's always going to be easy to find is what happens if I were to plug in 0? And this would be my y-intercept. So going to my original function here, if I were to plug in 0, that would be 0, 0, 0, 0. Well, all I have left is that negative 3. So this tells me that it's going to cross the y-axis at negative 3. I'm looking at my zeros right now. So I have 1, 3, and negative 1. So another good number to probably look at would be something in between these two. So positive 2. Let's look at 2. So same as before. What would happen if I were to plug in 2 to this equation here? Okay, so I went ahead and put that in my calculator. I didn't show it here. But if you plug in 2, it just so happens that you also get negative 3. Okay, so I'm going to use all of these points to help me sketch my graph. So it's not going to be the prettiest graph, but we're going to try. Okay, so let's go at least to 4. 1, 2, 3, 4. Same thing on the top. Okay, so my zeros were at positive 1, so I'm just going to put points. Positive 3 and negative 1. Okay, then looking at my table, I know that it's going to go through the point 0, negative 3. So that would be here, my y-intercept. And it's also going to go through the point 2, comma, negative 3. So on my graph here, it's hand-drawn, so it's kind of messy. But I'm going to try my best. 1, 2, and then negative 3. 1, 2, 3. So somewhere around there. Okay, the other thing that I know is that from my end behavior test, both sides are going to point up. So on the left, it's going to point up. On the right, it's going to point up. Other thing I know is about the multiplicities of these. So at negative 1, which is right here, it's going to go through it. At this one, at positive 1, it's going to bounce. And then at positive 3, it's going to go through. Okay, so now I want to put all this together, and let's see what I can come up with. It would be through, bounce, through. Both sides are pointing up. Okay, so that's how you would sketch your graph. This is pretty close to what it should be. If you use your graphing calculator, it would be a lot easier so you can compare what you got to the actual graph. Okay, now our division. Use long division to divide here. So always double check that your polynomial is in descending order. So x3, x2, x, and then constant. So we are good. So we're just going to divide it as is. So we're going to put our divisor on the outside. Okay, divisor on the outside. So 2x minus 1, and our dividend on the inside. 4x cubed plus 4x squared minus 7x plus 2. The trick here for long division is to only look at the first term. So we're going to start by 4x cubed divided by 2x. And that would give us 2x squared. Then you're going to multiply that term to each term of the divisor. So that would give me 4x cubed minus 2x squared. Subtract that entire expression. The first terms will cancel, but just be careful on the second one. You have 4 minus negative 2. When you have minus negative, that's essentially a plus sign. So this would be 6x squared, and bring down our next term. So now look at the first term here. 6x squared divided by 2x. Okay, so that would be 3x. Then get your 3x and multiply it to each term of the divisor. So 6x squared minus 3x. Subtract the whole thing. First one will go away, but on the second one, I have negative 7 minus negative 3, which means that we're going to add. So that'll give me negative 4x and bring down our last term. So looking at the first terms here, negative 4x divided by 2x, that would give me negative 2. Multiply it to the divisor. Subtract. And we have a remainder of 0. So our answer is everything that's at the top. Our official answer for this is 2x squared plus 3x minus 2. Okay, now let's do some dividing using synthetic division. But you have to still do the same setup with that polynomial. Make sure that it is going in descending order. So what I mean by that is x4. There should be an x3, but there isn't, so we're going to have to use a placeholder. Then x2, then x1. Again, we're going to need another placeholder, and then our 9. Okay, so here's how I kind of keep it straight of what I'm supposed to be writing. Since my first term has x to the 4th, I'm going to write that. And then if I were to go in order, it'd be x3, x2, x, and then just my plain constant. So when I write my coefficients, I'm going to do it underneath where they go. So if I have x to the 4th power, it technically has a 1. Then x to the 3rd power, I don't have anything that has x to the 3rd power, so I'm going to put 0 as my placeholder. X to the 2nd power has a negative 10 in front of it. Then x, I don't have a term that just have an x, so I'm going to put 0. And then my constant of 9. Okay, so when we're dividing, we're going to put this box over here at the top left. What do I put in that box? So I need the 0 of the divisor. So here's my divisor. I can't just put negative 3. I have to set that equal to 0. Add 3 to both sides. And then I get x equals 3. So you need to put positive 3 up here in the box. So be very careful with that. Okay, so let's start our synthetic division. Bring the first term down. And then 3 times 1 is 3, and add those numbers. 3 times 3 is 9, and add those numbers. 3 times negative 1 is negative 3, add those numbers. And then 3 times negative 3 is negative 9, add those numbers, and that is 0. That 0 is our remainder. But the rest of it, that 1, 3, negative 1, negative 3, is the coefficients for my answer. So since our first term was x to the 4th power, so see that here, and then I also wrote it here. When you write your answer, you always go 1 less, because if you divide it, it should be getting smaller. So this is going to be 1x cubed, I'm not going to write the 1, plus 3x squared minus 1x. So I'm putting the minus, but I'm not going to write the 1, and minus 3. That is our answer. What it is right now, it's going to be long division. So like this number right here, number 5. I have a problem where I'm going to want you to show your work using long division. But other than that, the rest of it is multiple choice, so it should make it a little simpler for us. Let's have a few more examples. Use the remainder theorem to evaluate f of x equals 6x cubed plus 20x squared minus 15x plus 9 at x equals negative 4. So if it says remainder theorem, that means you're going to divide and you want to see what your remainder is. You could technically use long division, but in class we were using synthetic division. So I want the coefficients of my polynomial, just double check that it's in order. So x3, x2, x, no x, so we're good. Let's just write those down. Then in the box, I need it to be my 0. The good thing about here is if you're evaluating at a certain number, this is not a factor. This is actually x equals already. So you can go ahead and put the negative 4 here. And now let's do our dividing. Always bring down the first term. Now let's multiply. Negative 4 times 6 is negative 24. And add gives me negative 4. This gives me positive 16. Add gives me positive 1. Then this gives me negative 4. Add these together, and that's positive 5. So positive 5 is my remainder. So according to the remainder theorem, that means that if I were to plug in this number, negative 4, whatever I divided by, if I were to plug that in to the original function, my answer would be the remainder. So my answer would be that 5. Okay, number 8. Use the factor theorem to determine whether the given binomials are factors of the function 2x cubed plus 3x squared minus 17x minus 30. So factor theorem says that if the remainder is 0, then yes, it's a factor. If it's anything other than 0, then no, it's not a factor. But in this case, see how it's a factor? I need it to be x equals the way this one was. So I'm going to subtract 3 from both sides. Subtract 3. So x equals negative 3. That's going to go in the top left box. Then I need the coefficients from my polynomial here. So 2, 3, negative 17, negative 30. And let's do our dividing. So bring the 2 down, then multiply, so that's negative 6. Add. Multiply, add, multiply, and add. So our remainder here is negative 6. So what's important is that, well, that's not 0. So no, x minus 3 is not a factor. So is not factor. Okay, so what about x plus 2? So same as before, I need it to be x equals. So we're going to move that 2 to the other side. And that gives me x equals negative 2. So in our box, we're going to put negative 2 up here. Then let's write the coefficients from up above. So 2, 3, negative 17, negative 30. Okay, bring down the first term. Then multiply and add. Multiply and add. Multiply and add. So there we go. We had a remainder of 0. So for this one, yes, x plus 2 is a factor. Okay, and last thing that we did, so this is from yesterday, is we want to find the zeros and we want to write this polynomial in factored form. So first we're going to use the rational zeros theorem to find all the possible rational zeros. So remember, we're using the form p over q. P comes from the last number 2. So what are the factors of 2? This is going to be a short problem because 2 is prime. There's only 2 options, 1 or 2. And then for q, that comes from the first number. And same thing. So what we have is technically 4 fractions in 1. So I have 1 as a denominator of 1, 2 with a denominator of 1, 1 with a denominator of 2, 2 with a denominator of 2. So let's just write all of these out. 1 over 1 is still 1. 2 over 1 is still 2. 1 over 2 is 1/2. But 2 over 2 is just 1 again, so I'm not going to write it. So I have 6 different options, technically. Positive 1, negative 1, positive 2, negative 2, positive 1/2, negative 1/2. So now it's telling me let's find the zeros. So let's just start at the beginning. Let's start with positive 1. Or actually, you know what? I'm going to start with negative 1. So let's put negative 1 here. And then now I need my coefficients for my polynomial. So 2, negative 3, negative 3, 2. Bring the first one down. Multiply and add. Multiply and add. Multiply and add. So good. First try, we already found one that's a 0. So x equals negative 1. That's important. We're going to need that later. But let's look to see what we have left over here. If I were to write this as an answer, this would be 2x squared minus 5x plus 2. That's a quadratic, so we can solve that by factoring. A, C, B. So 2 times 2 is 4, and we are going to need it to add up to negative 5. So 4 has 2 options, 1 times 4 or 2 times 2. The problem here is that 1 plus 4 is positive 5. So it's close, but it's not exactly what we want. But what if we had negative 1 and negative 4? If I multiplied them, I would still get a positive because negative times negative. But when I add them, that gives me my negative 5 like I need. Okay, then we need to divide by 2. Since I had my leading coefficient of 2, we're going to divide by that. That first one, that fraction, let's move this 2 up. And in this one, 4 over 2 is just 2. Now that I have my factors, I can set them each equal to 0. So this one tells me that x equals positive 1/2. And if I set this one equal to 0, x equals positive 2. So now I have all three of the ones that I need. So if it says find the zeros, we got them. It's negative 1, positive 1/2, and positive 2. Okay, then part C says write the polynomial in factored form. So we're going to get the factors directly from the zeros. We kind of already did this problem at the very beginning. The good news is that some of the work is already done for us, because for 1/2 and 2, if you follow backwards, we already have their factors here. All we need to do now is find the factor that goes with x equals negative 1. We're going to add 1 on both sides. So x plus 1 equals 0. That means my factor is x plus 1. So now that I have all three factors, let's write our polynomial in factored form. X plus 1, 2x minus 1, and x minus 2. Okay, and that's it. That's everything that's going to be on the test. So I know it's a lot. It'll be a little bit easier on the test because most of it is multiple choice. I have one question where I want you to show your work. So if you have any questions over anything, just let me know.